Eat it all, and you'll be good for a month. Does that work? Now let's split it in 30 portion or 90 portions, 3 meals a day, a little bit, and then take that every day. After 30 days, you're in vibrant health and everything is fine. It's exactly the same thing with your stem cells. Massive release for a short amount of time is very different than just having a little bit more every day. That's what these studies are showing. So the conclusion is that bone marrow stem cells constitutes the natural renewal system of the body, simply supporting the release of stem cells from the bone marrow. Putting more stem cells in the blood allows to combat entropy or aging or just the natural process of life. You just repair everything every day. How can I see that this is happening in real life? Because everything that I'm talking about is done on rats and mice and cats and different animals. How can you make studies that and show that this is happening in humans? You can't. Okay, it's not ethical to study humans like this. But there is a real life situation where you can see it. That real life situation is when a man receives an organ from a woman or when a woman receives a bone marrow transplant from a man. In both cases, what do you get? You get double, because what is the main difference between men and women? Aside from attitude. I mean, women having the better attitude. I have to be careful here. It is the Y chromosome that men have that women don't have. Women have the double X, men have the Y chromosome. Just like green fluorescent protein, I can also tag the Y chromosome and follow it in the cell. So in that situation, I have the tissue. Okay, I have, in that situation, what I have in both of them. I have the organ, let's focus on the men right now. The liver comes from a female, from a woman, so it doesn't have the Y chromosome. But the men's bone marrow have the Y chromosome. In the other case, the woman's own organ don't have the Y chromosome, but the new stem cells have the Y chromosome. So if this is a true phenomenon, stem cells should leave the bone marrow and go to any organs. In the case of men who received a liver as a transplant, what they did is that they went back into bank of biopsies, samples of tissue taken after a transplant if there were any problem, and they just analyzed these tissues for the presence of Y chromosome. And what they found is that between 4 to 12 months, these were the people involved in the study, up to 16% of the liver, of the cells in the liver, had the Y chromosome. 16% of the liver had already been replaced within that time period. But one individual who passed away after 4 months and a half of serious complication, 40% of his liver was his own liver, made of his own stem cells. Okay, now let's look at the data that we have on STEMinence, which is the work that we have done. Everything that I'll be talking about was published about a year ago in a journal called Cardiovascular Revascularization Medicine. We gave people AFA and we quantified the number of stem cells in the blood. First, we didn't see anything, but it was such a great idea, so we kind of kept working on it. And one day, we started to give people more and more. And when we start to give people more than 5 grams a day, then we start to very consistently see this effect. An increase in the number of stem cells of about 25%, 25 to 30%. That would peak at about an hour and then come back to control. So the effect was there. But because people need to take 5 grams, it is something that is very difficult to market. If we tell people, well, take 10 to 20 capsules 2-3 times a day, it's not very easy to do. It would be like consuming a bottle of capsules every day. So we had to identify the active compound, how it's working, what it does to explain this whole phenomenon. So that's what we did. So in the bone marrow, so this is to represent a bone, with in red the bone marrow, the cell, and on the surface of the cell, a protein called L-selectin. When L-selectin is activated, it leads to the expression of a baseball glove called CXCR4. It's a receptor. It's a receptor that is specific for a molecule called SDF1, stromal-derived factor 1. If you remember well, SDF1 is the molecule that is released by an injured tissue to call for help. So the same phenomenon taking place in an injured tissue takes place naturally, without injury, without anything. It's just natural health in the bone marrow to keep the stem cells in the bone marrow. When these two connect, so SDF1 with CXCR4, the receptor, it leads to the expression of an adhesion molecule that makes the stem cell grab the bone marrow and stay attached to the bone marrow. Anything you do to prevent or interfere with this phenomenon, you will trigger the release of stem cells from the bone marrow. We thought we probably have in AFA a blocker of L-selectin, that molecule here that is at the surface of stem cells. If we have a blocker of L-selectin, we block its activation, we don't have the expression of the receptor, we don't have the connection, we don't have the adhesion molecule, so the stem cell loses its ability to hang in the bone marrow. So far, so good? Okay. So how did we determine if we do have something that binds to the L-selectin? In science, a ligand is a molecule that binds specifically to something. That's what a ligand is. So we thought we have an L-selectin ligand in AFA. An idea. We don't know if we do have one. So what did we do? We essentially, it's an ingenious protocol I did not design, Dr. Jensen did. Took a magnetic bead covered with a protein, specifically it's kind of a glue, and in it we stuck L-selectin molecule. Now, I show only one here, but think of it as a hairball where you have, hundreds, if not thousands, of these little L-selectin going around. It's a magnetic ball, so if I put it in water, it's easy to put a magnet, and they all stick to the magnet on the side, and then I can collect them. Okay, so what we did is that we took this magnetic ball with the L-selectin on it, and we put it in a solution of AFA. If I have something that binds to L-selectin, I'm going to collect it on the L-selectin molecule. I don't know if I have it. So what I do is I put it with AFA, I wait a little bit, I put my magnet, I collect all these beads, and then I wash the liquid thoroughly until I have pure water, and then I remove the magnet, so I have these beads now that floats into pure water with or without a ligand that bound to it. Remember, I don't know. This is a study that I do to determine this. So now I have this bead with or without the molecule. There are ways to cut this bond so that molecule gets released from the L-selectin. So I do these techniques, I release that molecule, then I put the magnet again, collect these beads, and now I take the liquid. So in that liquid, if there is a molecule that specifically binds to L-selectin, I have isolated it. We have determined that we have in stem enhance a ligand that binds to L-selectin. It could be an activator or a blocker. Through various studies, what we have shown is that it is a blocker. It does not activate L-selectin, but it prevents the activation of L-selectin. So when we concentrated this compound and then turn it into a product that is now known as Stem Enhance, and then we feed this concentrate of AFA to people, we get the same release of stem cells from the bone marrow with the same increase in the number of circulating stem cells of about 25 to 30% with only 1 gram of Stem Enhance. That's the work that we have done, identifying the active compound and then concentrating the product so that we can, with 1 gram, get the same effect. As we were doing all this work, we also discovered something. It was a puzzle. It took us 2-3 years to do this work. It would have been much easier had we known this when we started. We have 2 compounds in AFA that affect stem cells, and they have an opposite effect. So think about this. I mean, not easy to resolve this puzzle, but at one point it became very clear, and we did identify these 2 compounds. There's a compound that blocks L-selectin, and there's also a polysaccharide that supports the migration of stem cells out of the blood into the tissues. So as you consume this product, the number of stem cells in the blood actually decrease as stem cells leave the blood to go into the tissues. So you have the graph here shown by both. So what is Stem Enhance? It's a blend of these 2 compounds, these 2 concentrates from AFA, the L-selectin ligand or blocker, and then the polysaccharide blended. So 1 gram of Stem Enhance supports both the release of stem cells from the bone marrow and their migration into tissues. Now, there's an easy way to summarize all of what I've talked about right now in a very, very, very simple message. Think of health as a balance between 2 phenomena in the body. I have, on one hand, entropy, which is, let's call it aging, going down, slow breakdown of tissue. On the other hand, I have rebuilding, which is what your stem cells are doing. Your health will be determined by what is going on in the body. If the rate of aging going down is bigger than the ability to rebuild, you experience unwellness. If your ability to rebuild is greater than how fast you go down, then you will experience wellness or health. Cells die every day. It's a natural process, totally natural process. Stem cells replace these cells every day. It is a natural process. The faster you go down or the faster you rebuild will determine your overall health. And what will determine how much you go down? I will say it's the sum of a number of things. Your genetics, your past injuries, your lifestyle, your diet, your exposure to environmental toxins, your level of stress, your mother-in-law. Put all of that into a bag. Shake the bag. That is the stress applied to your body, for which stem cells need to sort of rebuild or make up for.